This is section 2.6. This will be the second video. We're going to look at theorems. The reasons used in a proof can include definitions, properties, postulates, and even theorems. Theorems are going to be statements that can be proven. Once you have proven a theorem, you can use the theorem as a reason in other proofs. So the big difference between a postulate and a theorem is postulates are facts. You can use them right now. Theorems, you need to prove these statements, and then you can use them to prove other things. So there's two theorems here. There's theorem 2.1, which is on the congruence of segments, and there's theorem 2.2, which is on the congruence of angles. They basically say the same thing. We're talking about reflexive, symmetric, and transitive properties that we already know. If you have a segment, it's definitely congruent to itself. That's the reflexive property. Same thing with angles. Any angle is congruent to itself. The symmetric property works for segments. If two segments are congruent, they're congruent this way, or if you write them this way. Same thing with two angles. They're congruent this way, and they're congruent that way if you reverse it. The transitive property, remember, we have two different things that are congruent to the same thing. So those two things are congruent to each other. That works with angles too. We have two different things congruent to the same thing. So they're congruent to each other. I'm assuming we're looking at these because we're going to use them next. We're going to prove this property about midpoints. If you know that point M is the midpoint of segment AB, prove that segment AB is 2 times the distance from A to M, and the distance from A to M is 1/2 of the distance from A to B. Okay, so here's your given. They're telling you M is the midpoint of segment AB. Can you show these two things? Can you show that this distance is twice this distance? Can you show that this distance is 1/2 of the whole thing? Well, let's use a really simple example. Let's say M is the midpoint of that segment. Let's pretend this segment has a length of 10. That would make each piece 5. Distance from A to B is 10. Is that equal to 2 times this distance? 2 times 5? Yeah, they're equal. How about A to M? That's 5. Is that equal to 1/2 of the distance from A to B? 10. It is. So you should be confident that this is a true statement. You just need to show that it works for all cases, not just this case. Okay, so our first statement is going to be to write the given. Oh, this isn't good. M is the, sorry, it's sloppy. M is the midpoint of segment AB. That's given. Well, if that's the midpoint, what does that mean? That means by definition that these two segments right here are congruent. Tell you a little secret here. If you're using a term as a statement, most of the time, the next thing you're going to do for a reason is define that term. If you're saying something's a midpoint, we're going to come over here and say, well, what does that mean to be a midpoint? Use that definition. It means these two things are congruent. Now, if these two things are congruent, notice how the third reason is saying to use the definition of congruence. What does it mean to be congruent? It means those two segments have the same length. Okay, so that's what we gathered from this given. Now, we're taking a little bit of a detour with this statement. You have to kind of look up here at the diagram. Distance from A to M plus distance from M to B. That equals distance from A to B. That's little plus little equals big. Segment, addition, postulate. We're going to substitute something here. And I'm going to kind of look forward here. I can substitute something in for one of these. It doesn't matter which one I replace, because I notice that these two things are equal, right? These two things are the same. So I need to substitute one in for the other. But I want to end up with 2 times the distance from A to M. So I'm going to take this guy out. So for the step 5, it's going to take a little bit of time to develop this vision and this thought process. But if you look around, you should be able to figure out that I'm going to take something out and put something else in. That's what substitution is. So what should I take out? Since this guy equals distance from A to M, that's going to be my move. And I know this is going to work out because distance from A to M plus distance from A to M gives you 2 times the distance from A to M. So all we did there was we simplified. I combined these like terms. So this is half of what we wanted to prove. Now the other thing we wanted to prove was how far it is from A to M. Well, to get distance from A to M by itself, you could divide both sides by 2, but notice how it's using the multiplication property. So we're not going to divide both sides by 2. We're going to multiply both sides by 1/2, because if you multiply this by 1/2, you get this. If you multiply this by 1/2, you get this, which is what you wanted to show. Here's some tips for writing a 2-column proof. In a proof, you make one statement at a time until you reach the conclusion. Because you make statements based on facts, you're using deductive reasoning. Usually, the first statement and reason pair you write is given information. So if we're given that 2 angles are congruent, you can copy or draw diagrams and label given information to help develop these proofs. If 2 angles are congruent, that means their measures are equal. That's the definition of congruent. Remember that little hint I gave you on the last slide. We're going to use definition of congruence a lot. Now, if these 2 measures are equal, aren't they equal if you reverse them? That's the symmetric property of equality. Now, if these 2 measures are equal, doesn't that mean that the angles are congruent? That's definition of congruent again. We proved that the symmetric property of angle congruence is true. We were given 2 congruent angles. Are they congruent the other way? Sure they are. We used the definition of congruence and the symmetric property of equality to prove that. Okay, now let's talk about these other hints here. We're going to use definitions, postulates, or proven theorems that allow you to state the corresponding statement. So these are your reasons. They're definitions, postulates, theorems. Make sure you give a reason for the last statement. The number of statements will vary. Sometimes it's a 4-step proof. Sometimes it's 5 or 6 or 7. These statements are based on facts that you know or conclusions that you can draw from deductive reasoning.